Okay, so this lesson is improper fractions, part 3. So part 2 is some worked examples with comparing improper fractions. And this lesson is going to be working with adding or subtracting improper fractions. So what I'm going to do is explain the two methods that you can use to add or subtract improper fractions. So the first method you can go with is the mixed numbers method. So let's say we have something like 5 and 1/4 plus 2 and 1/4. So the first thing you have to do is check to make sure the denominators are the same value. And you know what, actually, for the sake of this lesson, I'm going to make this 3, just to show that extra step. So first thing you want to do is check to make sure the denominators are the same value. In this case, they are not. So we're just going to have to do some converting. You want to check to ensure that you can subtract without resulting in a negative number. So this addition problem, we won't encounter that, but the next worked example, we will have a situation where we have to do some more kind of manipulating so that we're not subtracting a negative, not subtracting to get a negative number. And then you want to treat your whole numbers and your fractions kind of separately as you add. So first thing I have to do is I have to find a common denominator between the 1/4 and 1/3. Um, I am familiar with the lowest common multiple of these two. The lowest common multiple of 4 and 3 is equal to 12. So now I need to choose a value to multiply this first fraction by. To have a denominator of 12, that's going to be 3. And whatever I do to the top, I have to do to the bottom. Oops, that's kind of small. There. And then for this fraction here, I have to choose a number to multiply 3 by to get 12. So I'm going to choose 4. Whatever I do to the top, I have to do to the bottom. I just want to point out that when I'm multiplying this fraction by 4, I'm not changing the value of the fraction. I'm only changing the way that it looks. And I'm just going to switch it around so that I'm able to add, because we cannot add unless our denominators have the same value. So in case that's a little bit confusing, I'm not doing anything to change how much is there. I'm just changing the way that it looks. So now I have 5 and 3/12 plus 2 and 4/12. Great. So like I had mentioned, I want to treat my whole numbers and my fractions different. It's almost like two little sub-addition problems. So I'm just going to highlight the fractions in that cyan color and the numbers in red. So all I'm going to do is I'm going to start with the whole numbers. 5 plus 2 equals 7. And then I've got 3/12 plus, oopsie doopsie, 3/12 plus 4/12. So whenever I'm adding fractions, my denominator stays the same. And I'm just going to add 3 plus 4. We can write it like this. And then I'll just write it again over here. 7/12. And I'm done. So I just added two mixed numbers together. They had different denominators. I'm checking to see if I can reduce this anymore. I've got 7 in my numerator, and I don't see that 12 as a 7 is not a multiple of 12. So this is in my fully reduced form. I'm done. So this is method A. We can also do method B or method 2 here, converting it to an improper fraction. And this is if you encounter a problem where you have two improper fractions and you're adding or subtracting, just leave them in improper fractions. This could be a little bit quicker. If you have to change your own denominators, you might end up with some really big funky numbers. So the mixed number may be better for that method, but if we were going to do this same problem as improper fractions, I'll just quickly write it in here. 5/4. Oops. There we go. All right, finally erased. 5 1/4 plus 2 1/3. I'm going to quickly convert this to improper fractions. So I'm going to multiply 5 and 4, and I'm going to add the 1. So 5 times 4 is 20. 20 plus 1 is 21. All over 4. Okay, I'll do the same here. 2 times 3 is 6. 6 plus 1 is 7, all over 3. Because my denominator doesn't change, it stays the same. So what I could have done is quickly converted these into the LCM, which regrettably, I think that might be a better solution. Sorry if you're following along there. What I'm going to do is I'm just going to take the work that I did up here and I'm just going to write this with the LCMs because it will just save us some troubles later. Sorry about that quick change on you. There we go. I've got some bigger numbers to work with, but never fear, big numbers aren't too scary. So I'm going to do 5 times 12, which is 60, and then 60 plus 3 is 63, all over 12. Okay, now I'm going to convert this into an improper fraction. I've got 2 times 12 is 24, 24 plus 4 is 28, all over 12. I'm sorry that this got a little bit squishy. I didn't anticipate doing an extra problem, but I thought I'd just kind of show you the two methods on this page. So I'm going to add straight across as I can. I have 63 plus 28 all over 12. And that gives me, 31. Oops, I should go the other way. 71, 91 over 12. Okay. So now maybe I want to convert this into a mixed number. So I'm going to ask myself, what is 91 divided by 12? It goes in 7 times, so that's going to be my big number there. Oops. Okay, I've got 7. The remainder is 5. Oh, pardon me. The remainder is 7, and my denominator stays the same. Kind of nice to convert this one into the mixed number because it confirms my answer up here. So notice the answers are the same. I did the same problem, just 2 different ways. If you ever need me to do another worked example of adding, let me know. I'd be happy to do a problem with the class. Okay, let's do this example here. So method 1 is mixed numbers. So it's kind of leaving it as is. Okay, so I have this problem, 20 and 3/7 minus 10 and 4/7. So this is going to be one of those situations where you might jump in right away. You see the denominator is the same. You're brushing your hands off and thinking, all right, I'm set to go. But then you go to subtract your fractions and you have 3/7 minus 4/7. Well, if I take away 4 from 3, I end up with -1. And we're not going to do that. No way, Jose. That's not really something we're equipped to deal with right now. Okay. So what I'm going to do instead is I'm going to change the way that this number looks. I'm going to do something kind of tricky here. So what I'm going to do, from this whole number here, from this 20, I'm going to borrow 1. Okay. So I'm going to borrow 1. Now it's going to be 19. I'm going to use a different pen color here. It's going to be 19. And then I borrowed a 1. 1. That's not a very good plus sign. I'm going to borrow 1 from that. So what 1 looks like in terms of 7, if I want to write 1 as a fraction with 7 on the denominator, I have to write 7 over 7 because any number divided by itself is actually just 1. So what ends up happening is I can kind of pull from my whole number to make this fraction have a bigger numerator, and that way I can still perform the subtraction. So I just did something a little bit tricky there, but fear not. It's not that bad once you practice. Okay. Good stuff. So now I'm just going to simplify this. 7 plus 3 is 10. All over 7. Keep my 19 there. Minus 10. 4 over 7. So now I have a mixed number problem that I'm equipped to deal with. So I'm going to take 19 minus 10, and I'm going to get, sorry, it's getting a little bit late. 19 minus 10 is 9. And then I've got 10 over 7 minus 4 over 7. 10 minus 4 is 6. All over 7. And I'm done. So I just had to do that kind of tricky operation. I had to pull 1 from my 20 because I can't subtract fractions and get a negative value. We're not quite equipped to deal with that right now. I'm sure I've seen that when I studied math in university, but I'm going to have to take a closer look what happens when we do that. Sorry, I'm just plugging in my tablet. It's a little low on juice. There we go. Okay, so let's try method 2. Let's try. Method 2 is improper fractions. Let's convert to improper fractions. Okay, so we have 23 over 7 minus 10, 4 over 7. When I convert, I take my denominator and my whole number, and I'm going to multiply them. When I do that, I get 140, and I'm going to add 3. So I have 143 all over 7 minus, same thing here, 7 times 10 is 70, plus 4 is 74, all over 7. Okay, so when I subtract those, I end up with 69 over 7. And I may be asked to show my answer in a mixed number. So I'm going to convert this into a mixed number. I'm going to divide, ask myself, how many times does 9 go into 67? And I'm going to say 9, because 9 times, 9 times 7, 63. And that gives me my denominator there, and my remainder is 6. So you might ask yourself, why would you go through the headache of the last problem, converting all those numbers? Well, if you feel more comfortable doing it with this method, it might be a little bit easier for you. So this is using the improper fractions. Make sure you're comfortable with converting between improper fractions and mixed numbers. And that's all for my worked example. Hope you found this helpful and meaningful.